Okay, good morning, and welcome to a most timely panel on modernizing military aviation. As one of the members of the AAA Aviation Guiding Coalition, I've had the opportunity to see all of the plenaries and Forum 360s come together over the past year, but I am especially excited for the discussion we're going to have this morning. Earlier this year, Secretary of the Air Force Frank Kendall published a memo that many of you have likely come across on reoptimizing for great power competition. In it, Secretary Kendall emphasizes the rise of peer adversaries who are placing new demands on not only the capabilities needed today, but the overall system tasked with ensuring ready and responsive forces into the future. From Eastern Europe to the Middle East and the Indo-Pacific, we're witnessing massive shifts in the global security landscape, as Assistant Secretary Ravi Chaudhry spoke to this morning. The very nature and character of conflict are changing, but especially in the speed, the complexity, and the uncertainty with which these threats continue to evolve. We are, in the words of Secretary Kendall, faced with a pacing challenge. Whomever can recognize and respond to the strategic environment the fastest possesses a significant advantage over everyone else. If we build the right thing too late, or for too great an opportunity cost, there will be dire consequences. We must maintain the initiative. Military aviation is thus undergoing a paradigm shift from traditional platforms to a strategic emphasis on capabilities. This evolution reflects a forward-looking approach that transcends individual aircraft or aircraft systems, instead concentrating on a broader spectrum of operational effects and outcomes. And today, we've assembled 4 experts from the Air Force, Navy, and Army, who are going to speak to their work in this time of great power competition. I'll briefly introduce each of them. However, their full biographies are available on the AAA Aviation program. First up, we have Trenton White. Trenton is an aerospace engineer in the Air Force Research Lab, or AFRL, specializing in configuration aerodynamics, multidisciplinary analysis, and design. And currently, he is the manager of the Off-Board Sensing Station, or OBSS program, perhaps best known for producing the XQ-67A. Next up, we have Barth Shenk. Barth is a senior design specialist and technology strategist with AFRL, having led advanced aircraft design, test, and evaluation through all stages of technology development over the span of 37 years. Barth additionally has 24 years of experience in strategic planning and investment decisions on air mobility. We also have Dr. David González, the acting director of the Naval Air Platforms Division within the Office of Naval Research. David's technical expertise covers aerodynamics and propulsion of solid rocket motors as well as conventional and guided munitions, with a view to furnish the next generation of air vehicle platforms and weapons. And finally, we have Dr. Robert Scott. Robert is an aircraft designer for the US Army DAVCOM Aviation and Missile Center and a subject matter expert in aircraft lifecycle cost analysis. His work has supported several Army aviation modernization programs, including crewed, autonomous, remotely piloted, and alternative propulsion systems. Each of our panelists today will deliver a brief 10-minute talk, and following their remarks, we'll engage in some Q&A on current trends in technology, in program management, and of course the broader geopolitical context as it relates to the future of military aviation. And as with previous Forum 360s, I look forward to receiving your questions that will make this an engaging panel. So without further ado, I'd like to invite Trenton to deliver his talks either from his seat or at the podium as he sees fit.
Thanks, Jeremy. Military aircraft currently takes too long, the development takes too long, and it costs too much. We need to be able to respond rapidly with affordable mass, but as you can see in the chart on the upper right, the cost of military aircraft has been rising at a rate of 7 to 12% per year. I've quoted one of Augustine's laws here, Law 16, that says in the year 2054, the entire defense budget will purchase just one aircraft. And while that was intended to be tongue-in-cheek, you can see that the trend that we're on is leading us in that direction. We have to be able to break that. Why is this happening? Economy-driven costs have gone up, but those have mostly been offset by increased productivity. So when we look at the real cause, it's most likely customer-driven. It's our fault. We're asking for too much in terms of the technical characteristics of the vehicle. It makes the system complex. And we also have procurement rates that are maybe lower or inconsistent with what's been proposed or originally planned. The other problem is that things are going too slow, and our years towards initial operating capability or our time to market have been escalating. You can see that in the dark blue plot on the lower right there. So when we look at other industries, for example, there's a couple unmanned points in dark green there, and commercial aircraft, those aren't rising at such a high rate. Can we leverage commercial models? When you look at the automotive industry in the brown or dark orange there, we see a decrease in time to market over time. One thing that we may leverage here is that the automotive variants are all built or share a common chassis. Maybe that helps to speed up development. So we intend to leverage these best practices of a concept called platform sharing that is enabling product line engineering for a family of systems that leads to lower overall cost and faster speed to ramp or time to market. We started a project in 2019 called Low Cost Insurable Aircraft Platform Sharing, or LCAPS. And within that, we studied the core foundational platform architecture, or a genus, from which we could build out and design and build out 2 different aircraft variants or species off of that shared platform. And the concepts were sensors. We have a concept called Offboard Sensor Station, or OBSS, and shooters. So the concept there is we call Offboard Weapon Station, or OBWS. We found that there are trade-offs between the cost of labor and time savings and things like how much variation you would have out of the different species, and the overall effectiveness of the family of systems. So I've showed some examples of how it's been done in industry in the past on the lower left, and on the lower right, an example of how it might be done for aircraft with the highly maneuverable aircraft technology platform, where they had different plug-in wings or tails or exhaust nozzles, but you have this core platform that's highlighted in blue with a center body, wing stubs, and an inlet there. So after the success of LCAP studies, we went forward with a project called the Offboard Sensor Station. We selected that as the variant that we wanted to design out further, build, and test. And I want to take a step back here because the foundation for LCAPS and this effort was started with an in-house clean sheet design team. This was a team that we had in-house that developed a multidisciplinary analysis and design optimization tool set. And then we exercised that tool set to characterize the design space for this new type of aircraft. And this made the government smarter buyers. It helped us to have a better understanding of the design space, some of the disciplinary interactions, and it helped us ask for the right things from industry. It also gave us the opportunity to build a team at the grassroots level with a network that has been established and it continues to pay dividends. So I'm highlighting some of the successes here. I'd also like to show a brief video here that illustrates the results of a design process or design optimization process that we ran. And the 3 axes here you can see are range, tactical altitude, and cost. Where you want to be for the optimal utopia point is up in the upper left where we have the star. And you can see that over time, as we're running this genetic algorithm, a front of best designs start to establish where you can't get better in one objective without having to trade off in the other. Well, we're rotating it here. I'm showing the initial generation that we ran as in comparison to this best set in blue that we're showing. Also showing on the left-hand side some of the configurations, the shapes that we got to that are indicative of the best in each one of those metrics there. So you can see, based on a random scatter shot of the design space initially and how much better that we can do. We get to this very quickly. So this is a big celebration of the successes that we've had in digital maturation. And we've proven this out now through rapid build and flight demonstration, through preliminary critical design, and the build and flight demonstration of a system that we call XQ-67A now. It looks like maybe that I had a video here that was prepared for the high-speed taxi, but it looks like that one didn't come through and work. So I'm going to go to the next slide here. And so the first video was an unveiling video that showed some of the high-speed taxi testing that we did. This one here, yeah, maybe can you go back and play the one video? Sorry. I don't know if you guys are seeing it there. Hopefully it's coming through. So this is our unveiling video that we released a couple months ago, showing the Air Force's concept car, XQ-67A, and giving you a glimpse here of what the future of the Air Force might look like. We had our industry partner, General Atomics, do the design, the build, and the testing of this system. And it was really exciting. I got to participate in almost all the testing activity, great moments, and we're really proud to show this new aircraft for you. So this was a really fun day at the track, but we were just getting started. Once we got through high-speed taxi, we decided to take it to flight demonstration. And I wanted to bring up a quote here. This is from the movie Ford versus Ferrari, also from a book the movie's based on called Go Like Hell. And in the book, in the movie, Carroll Shelby gets Henry Ford into the GT40 car and takes him for a spin. And he thought he was ready, but at the end he said, I had no idea. He kind of burst into tears, laughing and crying at the same time. And that pretty much captures my feelings about this, this test activity. So let's go ahead and play. This video here is of our experience of the first flight of Off-Board Sensor Station, or XQ-67A. I hope this gives you a feel for the excitement that we were feeling when we were out at the test site, getting ready to test, seeing the sun hit the aircraft. It's, you know, just really, really special. So here it is, taxiing out, ready for takeoff. Some great scenes there. This is one of my favorite parts right there, where it's coming in for landing. And we recovered it safely and a successful flight. So congratulations to the team. I want to celebrate here our successes. We started this 10 years ago, so it's been about a decade, where we created the concept of affordable mass. Here's a cover slide to prove it from Dr. Dave Walker at SAF-AQ. In the 2014 timeframe. Many had ideas at the time. We acted on those ideas and made them real. And now we have 2 generations of autonomous collaborative platforms to show for it, the XQ-58 on the lower right and the XQ-67 on the upper left. So how did we do it? First, we set a plan and we stuck to it. And sometimes there are some framing assumptions that might change. You may have to change your plan slightly, but try to stick to it as much as possible. Get commitment from the industry partners, from the others in the government. I'll leave out the story about Operation WD-40. Maybe we can talk about that later. We invited management out and leadership to experience it. That was really powerful, and it was like it became inevitable that we were going to succeed at that point. Finally, embrace and wield the power of public relations. We've seen the power in it, and encourage folks to do that as well. So in closing here, we learn the most through testing. Unfortunately, testing usually comes at the end of a project when money and time run out. Pulling a quote here from Secretary of the Air Force, Honorable Frank Kendall, that says, "We are out of time." So I'll leave this to everybody in the audience here. Are you ready to race? AFRL is ready. As a matter of fact, based on the last 10 years of work, I would say we're in pole position, or P1. Thanks.
Okay, so I'm not Trenton, so I'm going to roam a bit. I don't have a nice set of slides. I can't compete with that. I have the honor of working with Trenton and the horror of following him in a briefing. So I'm just going to go through and read through some of my slides, but I don't have slides presenting. But key thing that I pick up on now is taking up of we are out of time and what is the challenge now. I specialize in the adaptability world. What we've gotten from the great power competition is understanding that we built our entire logistics network, high infrastructure bases, very heavy, large centers of gravity that are now held at risk. So if you have to go halfway around the world and start punching, how do you do it when your major logistics centers are challenged and at risk? And all those neat XQ-67s need gas. Without gas, those things are paperweights. So we have to find a way to get all the sustainment things to them, because if we have a bunch of shiny teeth with no jaw, we don't have a force. And so what we are doing on the mobility side is responding to that evolving threat landscape and trying to find ways to make us less reliant on the large fixed infrastructure, leaner, smaller maintenance and logistics footprints, enhance fuel efficiency and resilience to energy infrastructure, because the major fuel facilities and all that kind of stuff, they're held at risk as well. So how do we lessen our sensitivity to if those supplies get disrupted? Speed. Not just in the sense of the platform, but in the holistic sense, okay? If we have to respond to something, how do we get there, okay? Get there quickly, but do it in a way that we can get somewhere and then we can reposition ourselves to go somewhere else. Because the place we're going to might get compromised. So we're gonna have to go someplace else quickly and reconstitute and then be able to deliver combat power when we're doing that. So speed means, okay, not just how fast can you throw the first punch, how fast can you throw the second one, the 10th one, the 100th one, the 10,000th punch. Our job in the mobility and the logistics world is to punch whenever we want to for as long as we have to. And so when we talk speed, we're talking about the entire process all the way back from the factory that affects that speed in getting things out. And connectivity. Everything that you've seen and heard about turns into information at some point. If we're disaggregated, but we need to communicate, we need to know where each other are, we need to understand the threat because we're in contested airspace, we have to have all that, but we have to have it real time, and it has to be connected. Right now, the way that we've been doing things, air tasking orders, things get scheduled, things get done. Schedules are out the window. We will have to be able to adapt on the fly. So that means being able to get access to information, process it, and share it very quickly. So those are the implications for next-gen mobility, because everything we have doesn't have any of that. We have airplanes that were largely designed in the 60s and the 70s and the 80s, and it's 2024. So the systems that we have, we're doing the best we can. Dr. Chaudhry was up here earlier talking about efficiency enhancements that we can do to the legacy fleet. But what about the next-gen fleet? And that's what's important to get out to you all, the men and women who are going to solve these problems. Okay, this is the aerospace community. The problems that we have are going to be yours to solve. We're going to try to define those problems as best we can, but this is what's out there for you. And it's an enormous challenge because we're living on a legacy of systems that is not suited to the environment we're going to hopefully not have to face, but might have to. So keeping current programs relevant, current platforms relevant is critical. So we upgrade them as best we can. But the promising technologies to get to mission level success, they're emerging. High efficiency platforms. Again, Dr. Chaudhry showed images of blended wing body. There are other things out there. We need to be able to skip steps in the process. We need to be able to go from continental United States directly to where the point of effect is that we need to reach without stopping intermediate, because those intermediate places might be compromised. So efficiency speaks to all that. So anything in propulsion and onboard power generation and airframes. All mission classes of vehicle. The tankers that we have, you know, they've been flying for forever. The transport planes, flying for forever. So tactical, or the tanker that we call NGAS, Next Gen Aerial Refueling System, Tactical and Strategic Airlifter, which is NGAL, Next Gen Airlift, and then Cargo UAS. Because right now, in order to get efficiency, you have to have different platforms that will work at different levels, but at high levels of efficiency. Currently, between like the C-17 and the C-130, we're turning every screw with the same 2 wrenches, okay? If you go to any mechanic's shop that's of any value, they've got socket sets where you've got the right tool for the job. So how can we get there? Multi-domain operations is another promising technology. For the first time, okay, now we're looking at using space as a medium for serious transport, okay? Ground-to-ground delivery through space is now within our reach, thanks to the entrepreneurial work and the venture capitalists that are out there that are moving the needle on that. So we have that. DARPA's working on sea-based things for Liberty Lifter, which is a seaplane. So this is probably one of the most exciting times to be in this industry that I can ever remember. When I first started, which was a long time ago, okay, you know, you worked for Department of Defense, or you worked for a defense contractor, or you worked for a commercial airframer, but that was about it. Not anymore. This is what's amazing, is where there's profit potential and where there's market forces, there's investment and there's growth and there's opportunity. So that's all coming. Next key thing for technology is automation at the platform level, the mission level, and the port and facilities level. And you know, some of the work that Trenton was just talking about speaks into that. Lean manufacturing. I have to hit this because, you know, my first X-plane was the X-55. Okay, somebody has to go first. The data that we learned from that program and the large unitized, co-cured, and co-bonded composite structures set the pace that said we've proven out the technologies that we need for things like XQ-57 or 67 and the other parts of that family, that we can do it. Now let's do it at scale. And so that's where we're at in advanced metallic fabrication and automated fiber placement. The key thing is, because we're out of time, we have to find ways of producing new platforms that are not dependent on rate to be affordable, or on numbers, quantity to be affordable. Because it used to have production runs of a couple hundred airplanes to make the unit cost acceptable. We have to find the technologies to eliminate touch labor, eliminate parts, things like that, that let us get to rate independent cost in terms of production, or largely in effect. Artificial intelligence, enhance the data collection, processing, and sharing. And the most promising development is this renaissance in entrepreneurship and venture capital investment, because the art of moving things is really rooted in commerce, right? So where there's commerce, there's opportunity for investment, there's opportunity for profit, and that's where you see the investment going, is people that want to make money, right? But along with that is coming all the innovation, the inventiveness, things that we're seeing in the eVTOL world, things that we're seeing with Elon Musk and with Blue Origin and the other folks. So where those forces are uniting is where there's opportunity, and it's largely unique to the mobility world. So this is probably about the most exciting time there is. There's a giant need, there's a lot of technology, and there's a lot of innovation. So I'm very happy to be at this stage of history where those things are all coming together, because I think some amazing things are about to happen, and I can't wait to see the next card and see how it goes. So that's all I got. Thank you.
Good morning, everybody. My name is David González from the Office of Naval Research, and I can comfortably say that Air Force definitely beat Army this time, so this is going to be a tough act to follow. But without belaboring that point, one thing that I do want to kind of communicate to all of you, and that they really elaborated upon very eloquently, is the fact of the tyranny of distance, like Dr. Chowdhury talked about a little bit earlier this morning. So from the point of view of how do we make our systems operate within those vast ranges and maximize the amount of capabilities that we distribute to the areas where they're needed, are very clearly some of the aspects that are universal throughout our joint services. So you may have heard within the Navy world, distributed naval operations, within the Marine Corps construct, expeditionary advanced base operations. All those concepts are all geared around the fact that we need to be agile. We need to be located and reach the locations that we need to when necessary. So this talk here, the charts that I have here, I'll go very quickly, are slightly different flavor from the perspective of they're not focused on any particular capability or program that the Navy or the Office of Naval Research is primarily focused on, but I just want to give you a sense of, from your perspective, this is what the Office of Naval Research is doing to try to contribute within that domain. So if you're not aware, the Office of Naval Research really is the S&T arm for the Navy. So our job is to reach out to all of you folks right here and get all the greatest ideas and try to put them towards the capabilities that the Navy requires. So from the perspective of as a force, we cover a vast range of domains. So we are definitely a multi-domain service, covering everything from space, surface, subsurface, and of course, where we come in as Code 35 is the Naval Air Warfare and Weapons Department. So very broadly speaking, we cover a broad range of funding opportunities and really pockets of money, developing everything from very fundamental science, developing molecules for whatever future systems or chemistry is required, all the way up to doing advanced technology demonstrations through various different applications. And they all are geared towards how do we deliver both the Navy and the Marine Corps, i.e. our naval forces, the capabilities that they require and need for the future engagements. I mentioned ourselves, the Naval Air Warfare Center. We're organized in 3 different divisions, primarily tackling naval air platforms, which is incredibly relevant to this community. This is where most of our engagements with the AIAA community really surface and are focused. We have 2 other divisions focused on weapons and directed energy systems as well. So within those constructs, we have right now kind of organized ourselves into 4 primary S&T objectives, i.e. areas that we're trying to find additional science to help us move the needle in modernizing our capabilities into the future. First and foremost, range is king, like we saw and talked about in the previous conversations. We need to be able to reach farther, and that's not just our offensive systems, but really our aircraft as well. That's a big aspect of what it is that we're trying to do. So all these operational energy enhancements, benefits are a key part of what we're trying to do. Because we are mobile, like Barth mentioned a little bit earlier, we need to reposition ourselves as necessary. We also need to be able to defend those locations effectively, whatever we need to take with ourselves. So building that defensive capability is also a big aspect of what we do as a department. The third bullet that you see here, sustainment, science and technology, might seem a little strange, but from the perspective of really all systems that the services build and deploy are very much spend most of their life. We spend most of our funding trying to keep those assets in the air, on the ground, on the sea surface, what have you. So what we're tackling here with sustainment S&T, what we're trying to mention here is the fact that we need to think up front of ways to make things more effectively supported in the field, i.e. how can we build or bring as much of the depot out to the field within this construct of still trying to be as agile as possible. So here, in terms of aircraft, for example, materials to minimize corrosion, which we operate at sea, and that's really our biggest challenge as a service, both for our sea vessels and, of course, our aircraft. But then doing all sorts of other technology developments with regards to data fusion, i.e. Condition-based maintenance. How do we know when we need to service our aircraft and our assets quickly and effectively and most effectively? And then last and not least is what this 21st century air operations and autonomy. What we mean by that is you probably have seen a ubiquitous shift towards autonomous systems. You saw the XQ-67 for the Air Force, but then that begs the question of if we're moving towards a mix of manned, unmanned, crewed, uncrewed, however you define those, how do we actually integrate all those systems into a cohesive picture, operational picture in the most effective way? We operate from aircraft carriers, so now you have uncrewed and crewed systems operating on a surface deck. How are we managing all of those assets? How do we bring all of those systems to work collaboratively towards the same objectives? Is really the crux of where that thrust for S&T is truly focused. Very briefly, I just wanted to touch upon ourselves within the Naval Air Platforms Division, just kind of giving you a very brief overview of how we're structured. But we pretty much have program officers touching every single aerospace discipline that you might consider within this organization here. So I myself am also dual-hatted as the aerodynamics program officer. That's my main duty. So communicating with this community, what our needs are, what are our challenges with regards to what our assets need to actually accomplish, and how do we build our fundamental science research portfolios is a big aspect of what we end up doing as program officers, connecting with the stakeholders, i.e. the operational community. And what are your headaches and what are the capabilities that you currently do not have, and how can I address those within my portfolio are really what we do as program officers on a day-to-day basis. But we have, again, aerodynamics is one, flight dynamics and control, autonomy, materials is a big aspect, again, like I mentioned earlier, power and propulsion, thermal management, and then I already mentioned flight dynamics and control, but you can see the breadth and scope of the various types of research that we're doing here. So it's all about, again, how do we build that capability, deliver the warfighter at additional range. We as a service are slightly lagging behind the Air Force with regards to what they're doing from the point of view of the low-cost attritable type platforms like you saw with the XQ-67. But what do those types of capabilities, what do those types of vehicles, what do we as a Navy need to imbue those systems with what capabilities? And then how could those complement what other services, in this case the Air Force, are doing, are also a lot of the conversations that we have on a regular basis. Last thing I want to touch upon and kind of impress upon this community is, again, as a service, we are Navy. We are a naval organization, so aerodynamics as an example, because I'm an aerodynamicist, so I'm a little biased there. But as a service, we need to focus on what are the unique challenges that the Navy has with regards to aerodynamics. What can I pull from all the other services that is ubiquitous to all of us, but then how can I complement that research or those developments in order to tackle the problems for us that we have? And we've done that by this so-called sea-based aviation national naval responsibility. And what that means is it is entirely focused on tackling the aviation problems that are unique to us as a Navy and naval service. Picture on the chart, first and foremost, is that we operate from surface ships, which present themselves as a very dynamic platform that you have to operate from. So we need to take into account all of those interactions of how these aircraft interact with all of the wakes that these very huge surface ships actually generate, and how do you navigate those meaningfully and effectively. This is even more the fact of operating a vertical lift system. You can imagine how that's exacerbated operating within the downstream of these types of platforms. So Aircraft capabilities that we need to think about as a naval service are shown here. Structurally, there are other unique aspects of that as well from the point of view of, I'm sure all of you have seen the pictures of a comparison between a naval aviator and an Air Force aviator landing on a flat surface. It is a controlled crash that naval aviators are trained to conduct, which necessitates the structures surviving those types of environments. So we operate within a very corrosive environment as well. So that is our single biggest challenge with regards to how to keep our assets flying and airworthy. And of course, propulsion systems associated with these platforms. How can we maximize performance for our future capabilities? So that in a nutshell, it kind of encompasses what we do in ONR Code 35 from the Naval Air Platforms Division. Many things are also applicable to this community from the perspective of what we do in kinetic weapons, i.e. how do we design our projectiles most effectively, and directed energy. So I'll give you a very quick example on the directed energy front from the perspective of not knocking out on the Air Force at all here, but with an operational, with a directed energy system traveling or operating from 30,000 feet or whatever that altitude is a slightly less challenging environment than trying to deal with a directed energy system right at the sea surface with all of the sea spray associated with that. The challenges that presents from an aero-optical perspective are definitely aspects of research that we tackle on a day-to-day basis. So just giving you a quick flavor of some of the research that we do, how are we trying to push the needle for the Navy and Marine Corps in the future. Those are some of the aspects that I think are critical and I wanted to communicate here. So without further ado, thank you very much, and I will hand the floor off to Robert.
Thanks, David. It's really exciting to be the one wrapping up this panel, particularly from my perspective in my career, to hear be talking about how we're going to design platforms to fill capabilities, and hearing the previous speakers have all talked about like actual technologies, and that's because I work in the field of conceptual design at the very earliest stage. Both quantifying and assessing all the things these guys talked about, hopefully getting them ready in the Army and our side to turn them into actual programs. So let me try to give you an overview of that and also cover a few things that are going on right now in the Army. Well, a lot of the sentiments in Secretary Kendall's words are mirrored in the Army Modernization Plan and Army Futures Command. We have 6 main modernization priorities. I work at Army DevCom, which is a subordinate command to Army Futures Command in the Aviation and Missile Center. So obviously, we were focusing on the 3 that are highlighted there: long-range precision fires, future vertical lift, and air and missile defense. And since I'm on the aviation side, obviously I'll be talking quite a bit about future vertical lift and a more recent program called Launched Effects that is a major supporting act to future vertical lift. So the office that I work in, we're headquartered in Redstone Arsenal, my hometown of Huntsville, Alabama, but I actually sit at Moffett Field, California, in the Concept Design and Assessment Group. And if you're not familiar with us, or myself or any of our colleagues, you may have seen some of our work in periodicals or in the news of the past decade or so, like the 2 concepts in the lower left. And that's because we actually do aircraft conceptual design in the government. Why do we do that? Well, simply put, it gives us an early idea of what are the right set of capabilities to chase. It defines the art of the feasible. And it also, in the process of doing that, it helps us expose and illuminate the technologies that we need to be investing in. Things, for example, like at a particular aircraft size, does it require an engine that doesn't exist yet that we would need to invest in? How do we do that? Well, it requires a lot of supporting activities and supporting cast as well. One of the ways we get a lot of practice in evaluating industry concepts, both traditional and non-traditional, like you see in the lower left as well. We're also co-located at NASA Ames with several other research scientists. We have an aeromechanics and aerodynamics group, both computational and experimental. We have a flight mechanics and a human factors group as well that leverage the NASA vertical motion simulator. We in the design office are really the integrators of all of the great research that they do. We put it all together to generate concepts like that. And in our office proper, we have to use a lot of models to do that. You may have heard of NDARC, the NASA Design and Assessment of Rotorcraft Code. Obviously, I'm talking a lot about VTOL aircraft being in the Army. That's really our primary tool. It was developed at Moffett Field. We, along with our colleagues at the NASA Aeromechanics Group, as well as principally the Navy S&T group at Pax River, are the principal users of NDARC, as well as occasionally the co-developers of it. We have some supporting tools as well to do layout of the type that you see in this slide. And we also do some deeper research into things like life cycle cost that I'm a subject matter expert in, aircraft optimization as well. And then successively going across the chart in order to keep those models current and accurate, we have to generate use cases, calibration data, truth data, in fact, to make them accurate. If this sounds like, as sometimes it feels like on our best days, this is making a career out of a senior capstone project, on the more stressful days, it feels more like, or we're reminded that the future of a program of record could be staked to the requirements that we help develop. So we do things like deep dives. And that is going back to first principles. Even though we're the conceptual design office, we have gone into the wind tunnels at Ames ourselves, looked at things like low drag rotor hubs or small electric motors for small aircraft. We've gone and made our own propulsion test rig, again for small UAS, and looked at the various details of different configurations from a conceptual standpoint. And that also allows us to do tech impact studies. So whereas the far left of this slide is the synthesis of putting it all together, we can also evaluate individual technologies, whether they're on a legacy platform or technology insertion to enable a new platform. That's a whole lot of things all tied together in one office. So I wanted to give you a brief example of one particular deep dive that we've done that I was involved in. For a technology that we saw coming on the horizon, would like to take an early stab at evaluating it. And that's this whole concept of an optionally piloted aircraft. Well, we had from subject matter experts a set of individual component buildups that gave us an idea that we could put into NDARC of the vehicle, the conceptual weight impact of what an OPV, or an optionally piloted vehicle, would look like. And we had to develop a cost model that integrated both the design itself, the CONOP of how you would fly an optionally piloted vehicle, how, for example, crew duty cycles would correlate to both the vehicle itself and the op tempo, if that would change. And we had to tailor that tool to a whole range of possible operating or modeling activities, both point studies of individual tech insertion, and then also sensitivity to measure the overall life cycle cost. Now, I've taken a lot of the numbers out of this chart to keep it simple, but the overall finding of that study was, yeah, sure, there's an impact, but it raises more questions than answers that we have to carry down the road. There's a trade-off, for example. An OPV is likely more expensive to buy and develop. But depending on how you fly it, and as this slide shows, in the best case, you actually might save some money and sustainment costs. That's the kind of finding that we can propagate through the Army enterprise to inform future requirements. In this idealized case, even carrying it forward into its life cycle, the natural question becomes, is there a place where a technology like that is cost neutral? And indeed, there is if you assume the best case scenario. But like I said, you have to go back to the user and ask them, well, how would you really fly an optionally piloted vehicle? More often than not, would you actually have a human in the loop? Or would you fully embrace that con-op? And that actually has a fairly dramatic effect on that cost-neutral point. So I think that gives you a great idea, hopefully, of the kind of sensitivity studies that we can do when we're at our best to facilitate the effective development of platforms and filling capabilities. I think we'll probably, in the upcoming discussion, talk a whole lot more about all sorts of trade-offs like that in promising technologies. Thank you.
Okay, fantastic. That now brings us to the Q&A portion of this. So as with previous Forum 360s, as I mentioned, if you scan the QR code, you should be able to submit questions, which we'll then filter out and be able to share with our panelists here. But to get us started, I want to take a step back and remind us that really the context for this is about capabilities, right? That's really what the panel is about, and that's ultimately what we're trying to deliver. And the word capability is being used very often. You have integrated capabilities, commands and offices, capability gaps. Many of you have mentioned capability several times. There are different definitions of capability depending on who you talk to. So I want to ask, what does the word capability mean to each of you? And how does the idea of a capability go beyond the idea of traditional aircraft or aircraft system? And whoever wants to start us off, you're welcome to throw your hat in the ring.
Yeah, sure, why not? My thought on that is when you say the word capability, yeah, there's a lot of definitions of it, and I think implicit is an outcome from where we sit, the capability to achieve an objective. Certainly in my office, if you glean that from my slides, our job is to distill something like that into quantifiable parameters for an aircraft. Those things, of course, are SWaP, like weight, speed, payload, range. Then going beyond that capability, of course, like I mentioned, is cost. Bit of a philosophical question, probably everyone else has their own opinion on it too, is if we can meet a certain capability but at an inordinate cost, then can we really meet it?
Right. Yeah, for sure. Okay, so thinking about it in terms of outcomes, but also the opportunity cost of what does it take to build and field that capabilities is important. Mm-hmm. Anybody else want to add to that? Or?
Yeah, so I don't know if my mic's on, but
Yeah, it's good.
okay, all right. So to pick up on something Rob had mentioned, so we think of it, I work very closely with the warfighters in terms of translating the desired effect and turn that into technology that the research community can solve. So when we think capability, it is what effect needs to be generated. And then that can be brought on by a system of systems, okay? And then each one of those systems will require attributes, and then those attributes turn into technologies. So when I am working with the warfighter and trying to find a way to translate, because that's basically what I am, is a translator, almost kind of like your eye doctor. You go into the eye doctor and you put your face in a machine and he just asks you two questions, better or worse, better or worse. But every time you answer that qualitative question, he's turning it into a quantitative answer, right? So when I work with the operators, that's where you start from, is the effect. And then as you keep dialing back in a Socratic method of working backwards from the effect, then you can back out the desired capability technology on the terms of what we call technology. But you start with the effect it needs.
Okay, fair enough. So I guess, thinking about capabilities as being published in policy or doctrine, there is that translation exercise, right?
Yes.
To bring it back to what we as engineers or scientists might actually building. Okay, that's fair. I guess shifting gears a little bit now. So I guess with that as a context, I wanted to ask then, what emerging technologies are each of you most excited about, and why?
I'll say maybe as an example, one that I'm excited about, and that I showed off a little bit of parts that we had success with in the OBSS and LCAPS program is digital engineering or digital material maturation. We're starting to see, and when we started LCAPS, in the 2018, 2019 timeframe, a lot of those tools were in existence but weren't widely used or making their way into the Air Force networks for use by us. And as we've started to progress over the last 5 or so years, we're seeing more capabilities come online or be available to us, more tools that are becoming more, standardized, more widespread use. And so we've tried to design the aircraft or the concept in a way that it would facilitate or be facilitated by that technology. And so that's something that I'm really interested in, taking advantage of, and could maybe help us go even faster in the future.
Okay, so the digital engineering aspect, anybody else want to chime in on that?
All of them. Seriously, love technology, but there's the single biggest emerging technology that is exciting is the actual, we're building things again. People don't tend to think of design integration as a technology discipline, but it is, okay? That's why orchestras have conductors. You have all these things out there that make noise, but somebody has to put it together to turn it into music, right? And for a long time, we weren't building many new systems. So with the advent of a lot of entrepreneurship and venture capital and some of the market-driven things, we're getting more of that understanding, and we're regrowing that ability to do the design integration process in a way that brings things forward. So that's kind of the technology I'm most excited about, because it's being reborn. There was a time when it was rampant, when everybody talks about the golden age of aerospace, but a new one's starting. And so that to me is the most exciting thing, is how do we take all these new elements, these different instruments, and turn them into new songs. It's fantastic, and that's what excites me the most.
Okay, so I guess that process, institutional, cultural, facilitation is what you're getting at. Okay.
Yes.
And I'd have to pull the thread on what Barth said. I agree 100% with everything that he just said, and at least within the Office of Naval Research, we're also trying to take a concerted effort in that direction from the perspective of not just the big technology demonstrations, which are key to future capabilities, but take a step back, even at the academic level, what could be achievable within an academic construct, and how can they also push the envelope a little bit with regards to totally understand this is going to be at a much limited scale and scope, but they also have a lot of innovative ideas, and they also have an ability to fail early and learn extensively. And they're not just bringing together the understanding of the technology in and of itself, but the key element that they're bringing as well is that future science and technology, or scientists and engineer cadre of individuals that will bring that mantra of let's build, let's get our hands dirty, let's push the needle as much as we possibly can, and really make an impact from that perspective. I think that is a key aspect. One area that I think a lot of that is taking place, I'm sure hopefully everybody agrees, but within the realm of autonomy, that brings a whole host of new questions into the mix that we need to get a good understanding of. So maintaining that ability to be okay with failing, But at the end of the day, what did we learn from that failure that we can integrate into our system, and how can we understand everything that we're developing to provide that capability to the end user, which at the end of the day is they're trying to do something totally different in a totally different way. We may not quite understand how to do that. And this is the pathway to providing them that understanding and capability.
Fantastic.
Yeah, I would echo a lot of what you guys have said, and maybe answer it in two parts. One thing that I don't want to ignore is really the traditional answer, which is the exciting new technologies that facilitate our existing platforms and future platforms are things like new engines, more efficient engines, lower weight structures, and all the novel ways we've seen, like in the technical sessions, to reduce drag. That's bread and butter. Now, the non-traditional way that I want to mention too is like some of us have hinted already, is this growing sense that the way that we need to fill future capabilities is leveraging things like network effects, whether it's autonomy or drone swarms. Army Futures Command has embraced a philosophy called the Army Warfighter Concept of 2030 to 2040 that envisions really the line of first contact in any near-peer conflict will be between robots or drones. That really opens the aperture from an aviation design standpoint. We're not thinking in terms of monolithic platforms, but perhaps one large one, or perhaps a 50-50 split, whether it's really a spectrum. One large one supported by a lot of small platforms, or a lot of similarly sized ones doing disparate jobs.
Okay, fantastic. I think, I guess one theme that really came out as you guys were responding to this is that at this panel is really where a lot of the technical discussions that you might otherwise encounter in aviation meet sort of the real world and the operational information and the kind of the stakeholder feedback, the operators, as you mentioned, Barth. So I kind of want to continue along that theme of program management and innovation coming together. I have one question here from the audience. How does the Air Force, Navy, and Army share technology or lessons learned, and how do they inform future capability planning?
I will say we don't do a well enough job, but we do our best.
Yeah.
But in all seriousness, some of you may or may not be aware, but there is such a construct as communities of interest at the Office of Secretary of Defense level. So overarching over all the services, there are distinct communities of interest whose sole purpose is to coalesce all of the services together and get those conversations going, essentially. So it's both a means of what have we done, what are we doing, and where do we need to go as a joint services, I should say. So there's a lot of conversations that do take place from that perspective with regards to how do we understand what directions we need to go technology-wise, and then make them happen. Now, do they always happen? No, not always. But every service tries to tackle their needs as best as they possibly can. And by all means, we are constantly looking to the other services with regards to what can I pilfer from them that they've already succeeded upon, so that I don't have to reinvent the wheel. And how do I tweak that in order to make it relevant to the naval surfaces forces in my own seat? So there are a lot of conversations. They are difficult conversations, and they are not always. They don't always go the way that you anticipate, but there's always lessons learned that I think, by all means, a lot of innovation does get translated across the services. Can we do better? Absolutely. And we'll continue to push on that as well.
Okay.
And I would add to that too that perhaps one of the funner and more innocent ways that we do actually steal some ideas from each other is, like, for example, David and I see each other occasionally when we interface with universities. So if we see, for example, any particular research lab, one of us showing a whole lot of interest in it, it probably gets the other's attention.
No, fair enough. No, those are all very valid points, and I think certainly something else that always comes up is, aside from those kind of formal institutional, communities of interest or otherwise, just building connections kind of like this and getting to know the right people is always a big part of it too, right? Totally.
The other aspect of that is how open each of the services are towards sharing that information, which I think there's a lot of interest and openness amongst the services. But just as an example, all the program officers at the Office of Naval Research, on an annual basis, we have our program reviews, and we do our darndest to be able to kind of communicate to everybody that's, depending on the topic that's being discussed, is if it's material, academic level material, that anybody can attend. We do broadcast that information to everybody to let them know what the fundamental research that we're doing. Obviously, when it gets to more of the specifics of the capabilities and very specific type systems, now it becomes a little bit more difficult. But there's still that connectivity, that reach out that we should all be doing with regards to, these are directions that we're heading. If you want to take a look at what it is that we're doing and see how it's relevant to you, by all means, come to this meeting or come to that meeting or share your thoughts, or why don't you give us your perspective on where we are. So at least as an ONR, we try to be very open from that perspective. And at least myself and many of my colleagues, we've had great success and participation from our counterparts in the other services. So it's been a very cohesive, collaborative environment that's fantastic to work within. So there's a lot of opportunities. I think we can still create some more.
Okay, no, that's fair. It's, at least that willingness and that desire is there, and that broadcasting of information to an extent is being done, right?
Yeah. And a catalyst for that is the sense of urgency that's kind of brought on, but because so I'm working heavily with the next gen tanker, okay, and this just tears my heart out to say this, but the Navy's leading in the introduction of autonomy and aerial refueling. They came out with the MQ-25. So we have the MQ-25 team fully engaged and integrated with us. Okay, yeah, you guys are first. I get it. But now share what you know, and they are. So that you need that catalyst. And then forums like these. So the sense of urgency is a catalyst as well for facilitating the crosstalk among the different engineers and disciplines.
Okay, no, fantastic. I guess a question specifically for Trenton. Obviously some very impressive work done with LCAPS between the X58 and then now the X67A, or XQ67A, I should say. Do you see all future acquisitions incorporating some elements of the LCAPS approach, be it low cost, open, flexible, or even attritable design, or alternatively, where do you think it's still important to preserve development of highly specialized systems that are maybe fielded in smaller quantities and take a longer time to build?
All right. Yeah, so I'd say in part, yes, but maybe I can characterize through an analogy here for everyone. So let's say, so there's, we would say exquisite and then maybe expendable and then something in between there, whether you want to call it attritable or whatever, more attrition tolerant. And so let's say that you just got done with a world-class dinner at one of these fine restaurants that we have here in the city of Las Vegas, and you decided that you want to go and have a nice cigar. So you get the cigar, get it cut, ready to smoke it, but you don't have something to light it with. So you could go and get a very nice Swiss Army knife with a blowtorch attached, or maybe a really, really nice lighter, right, that is going to be probably pretty costly, and it's going to definitely get the job done, right? Even in high winds and the worst kind of conditions, it's going to get the job done. At the same time, you really don't want to lose that. If you paid a lot of money for it, if you lose it, that's going to be really tragic, right? So we would say that the attrition tolerance for these type of exquisite systems is low, right? On the other end, we've got the expendable, which maybe would be like a match out of a matchbook, or maybe the whole book of matches. In good conditions, or for the one purpose that it has, it does it well. But then when you're done with it, you throw it away. In some cases, like in the windy conditions, right? Or if the cigar is drawing tight or something like that, then you might use up the whole book and still not be able to finish the cigar. So in the middle, we've got what we would call, I guess, more attrition tolerant systems. This could be like the Bic lighter, where it gets the job done. It still might not be as good in high winds as like a blowtorch, but it can get the job done. It's built in commodity, as a commodity. It's built in bulk, and it serves the one purpose that it's going to do very well. It still would be bad or suck to lose one, but it's not as big of a disaster or catastrophe as the more exquisite system. So that's the space that we're trying to play in here with this attritable or affordable mass concept.
Okay, so LCAPS is the Bic lighter sort of category that you mentioned.
Yeah, and I think that I would say, to kind of wrap up the question, or the answer to the question is that we need a mix of all of those, depending on the type of mission that we're doing, to really get it done.
Okay, no, I guess that's fair. I mean, as usual, the devil's in the details, and sort of you would expect there to be a spectrum. So I appreciate that framework for thinking about it. I guess harkening back to a previous question I asked, I'm curious if each of you can speak to a little bit about, you talked about what technologies or program management innovations are most exciting. Digital engineering, autonomy, the process changing. What are some technologies or technology areas that you think have underdelivered so far? And do you see a future for them? If so, what has to happen for that future to take hold? Without naming names. Yeah.
All right, I'll go. All right, and these, like I said, no shots fired, no shots intended here.
Yeah.
So a little bit of facetiousness here, but let's say eVTOL. I was hoping that we would have flying taxis by now. As a frequent visitor to the Southern California area and the Las Vegas area, it would really be nice to just be able to jump from the airport to your final destination. Are we going to see? I think we're starting to see some promise there and some real systems being built and flown. So at the same time, it's exciting. I'm a little disappointed as well.
Okay, fair enough. So time to market is definitely a consideration for that. Yeah. Anyone else?
To the eVTOL point specifically, I think having come to this and other forums regularly over the past 5 to 10 years, I think it is it's a testament to rational behavior, actually, that we've seen, a decade ago, incredibly optimistic projections of it, to where now the topics that come up, like electrics, hybrids, alternative fuels, they're speaking more my language as an aircraft designer, meaning they've migrated more to the tech sessions, and we're seeing objective, quantitative analysis of them, really finding the best mission for them. This is my opinion that I think is safe. It's like, if you're holding your breath for a Black Hawk replacement that runs on batteries, probably not going to happen soon. But it would also be a missed opportunity if we didn't embrace what we're seeing out of them. It's really a lot of new energy from all of those startup companies. And if we take advantage of it as best we can, probably offers us some new modes of operation that both our special users and maybe even the big Army could use going forward.
I may shoot myself in the foot for saying this, but this is David's opinion, but I'll say it.
Yeah.
But from the perspective of, I think it's a fantastic technology and it's been demonstrated to be effective. But to some extent, I think of active flow control as kind of fitting in this particular case, in the sense of under-delivering, not from the perspective of it doesn't work or it's not accomplished what it's intended to do, but from the perspective of it requires a totally different way of thinking. If we want to operationalize or utilize the full capability of these types of technologies, It's not just about proving out how much what aerodynamic benefit we can get out of or squeeze out of these particular systems, but it's how do we introduce that into a construct of an aircraft or system design perspective, which yes, there are efforts tackling a lot of those nuances. But we're not there yet, and there's still quite a lot that we could and should potentially do. But it all goes down to risk from the perspective of how much do we want to accomplish versus how comfortable we are with that. But there's a trade-off. To be comfortable with something, you need to be willing to, again, back to the failure question. You don't want to lose an aircraft just because you have a new technology, but how well can we understand it? What do we need to do to get to the point of being comfortable with integrating those types of technologies and novel ways of doing what we've been doing for the past 100 years in aviation, for example.
Okay, no, great comments. I got a few more from the audience here. I don't know if you can speak to this or to what extent you can speak to this, but we do have one question about, what do you see as being the key capability gaps that you're anticipating for the future, either near term or further out? To whatever level of detail you're able to speak to.
Well, I mean, I kind of highlighted one at the start of my prepared remarks there. We've got to move faster. We've got to be able to design and build faster and cheaper to be able to get to this vision of affordable mass. So I think we've done some of the foundational groundwork. We've laid the foundation here, but it's time to build on top of that and really start to show what we can achieve there.
Okay, so that message of we're out of time really coming through. Yeah.
Certainly, future vertical lift and FLORA. This is the Army's first program of record, or heading toward it, with a tilt rotor, and that represents a capability gap that we're trying to fill, a unique combination of need for range and speed.
Yeah, range, speed coming together with FVL. Yeah. Mm-hmm. Barth, did you want to say something, or?
Yeah, and I had alluded to it before. The ability to conduct mobility operations in terms of aerial refueling and sustainment operations to, through, and among contested airspace. We do not have a force that's designed to do that. And we got to figure it out quick. What we have is not designed for that kind of operation, and we're stuck.
I would echo all of those sentiments, but to add a different twist to this as well, and it's not capabilities related, but from the perspective of the future scientists and engineers, that is a critical gap as well. So how are we bringing up all the community here, for all the academics and mentors in this room? That is a huge need that we have as well. So who is going to take the mantle into the future and solve these challenging problems? Yes, we have dedicated and phenomenal people and teams working those problems, but that funnel, that gap, how we train the next generation, I don't think we have enough people, and we need to continue to try to incentivize the future generation and show them, these are some of the challenging problems that we have. These are some of the exciting technologies and things that we do as the armed services or within the defense environment that you could potentially tackle in the future as well. I think that's one aspect that we're very cognizant of, trying to mature and try to get more people interested in the science, in the STEM fields.
That's a great point. Like all of the technologies we're excited about require a whole of country kind of approach to actually be able to fill them, from people to the institutions and systems and everything else, right? I have two questions here that I'm going to merge into one. It's really about what do you see as being, or I guess, do you have any comments about the engines or power plants, propulsion systems that are going to be required for these new platforms, be it the XQ-67A and where that's headed, or others? How is the propulsion unit adapting? And I guess what are the messages as well for the propulsion community in terms of what should they be thinking about to be able to support your objectives?
Well, I could go and say, can we build it cheaper? Are there considerations because we're using this assumption that the aircraft is going to have a limited life, much shorter than what's typically seen in military aviation? Are there any shortcuts or different materials or things like that we could use to make it less expensive? It's difficult without big market demand signal to say go in this direction, but those are some of the needs. Probably increased electrical power or load on the engine than what's maybe typically seen in the turbofan engines. So that's something that I'd say we would also be interested in.
Okay, that's fair. So kind of programmatic aspects, and then given all the avionics demands that are now being placed on these systems, the electrical load piece. Okay.
And I'll piggyback on that and second to it, is not necessarily the engine necessarily itself, but onboard power generation and management. Because as we look and we have this legacy of taking existing airplanes, especially in the mobility world, and in any application, any change in capability comes at a cost of energy. Mm-hmm. And so everything takes kilowatts. Everything that you want, because almost nobody wants to give away the capability that they have. They want to add more. Okay, and that's true for commercial. It's true for anybody. People want better LCD screens in the back of their seats. They want more comfort. All that kind of it all accumulates. So for them to design the inherent capacity to extract power and to manage it, that's critical. Because it enables capability growth. At the end of every capability chain is an energy bump. And designing to accommodate an energy bump is that. Second thing is, which they're already incredibly prolific at, but as AI comes along and probably even get better, is the real-time, the system health monitoring aboard, because that gets back to the maintenance and logistics piece. Because if I cannot require a whole bunch of diagnostic equipment where I'm at, or if I don't have to have a big maintenance tail, that saves energy. It saves all kinds of sorties that we have to bring that stuff. So we have to move a lot of stuff just so we can keep moving stuff. Okay, so leaning that out. So having engines that are longer time maintenance time in between flight hours, the onboard health monitoring, and then design for excess power generation and management from the beginning is critical if you want to have an ability to grow and adapt to capability.
Okay, so there's the onboard kind of energy management aspect, but you're saying that whole element of force sustainment.
Yes.
Is something that needs to be considered as well,
yes.
Right?
And there's a shared commercial interest in that as well. So wherever we can find tie-ins where DoD needs and commercial needs tie together, those are goodness.
Okay. Sure. Maybe broadening that question, are there any specific S&T areas, again, another audience question, any specific S&T areas that you think the aviation community should be focused on to prepare ourselves for capabilities required in the next, say, 2 decades? Any specific ones that you want to highlight?
That's a loaded question.
I mean, it's kind of hard to say everything, but yeah.
It's a very, very, very good question and rather broad and all-encompassing. But so I'll pose it from that perspective, from the point of view of innovative aerodynamic configurations, and what are the implications on all of the other disciplines of S&T of some new unconventional ways of configuring your aircraft for a particular application. So I'm not saying that we're going to have individual systems to do very, very unique and niche missions or operations or what have you, but with regards to answering that range and speed question, what are novel ways of accomplishing that? What are technologies, be it aerodynamics, be it propulsion, be it autonomy, what have you? It's all about an integrated system at the end of the day. So how do we coalesce all these different disciplines to be able to accomplish that? So it's a very roundabout answer that doesn't necessarily get into any specifics, but that's just, at least from David's perspective here, that's the challenge. It's not just one discipline is going to bring the solution or an answer to what we need or capabilities that would potentially be deployed in the future. It's a collective thinking that's the approach that we need to take to be able to answer that call.
Okay.
Yeah, I would echo that. That's a great answer too, because the whole design and development process is so multidisciplinary. So I think as outreach to industry and to a certain extent academia as well, the best thing that we can pursue is interchange on what both individual technologies, but the synthesis of them as well. Like high-speed rotorcraft is a great example of, industry is pursuing a lot of compound helicopters. Some of them are based on legacy platforms and adding a few things to them. No one knows your platform better than the people actually building it. In my slide there, it really idealized the synthesis of an aircraft as parts coming together with some extra cost for integration. It really depends on, we know it's a lot more complex than that. And when you look at individual parts like that as fixed entities, that's not true either. We know, like, take propulsion for an example, that's a great one. Engines and their technical data really informs, I don't think there's another subcomponent more critical to rotorcraft design than that. I'd love to get more technical interchange from the propulsion community about all of the adjustments you could make to your engines to make them either a little more economical in one direction or a little more powerful, whether it's turning up the wick on the combustion section or adjusting some fan sections. As designers, we know these things exist on a spectrum, and we'd probably like to talk more about it with you.
Okay, so definitely some nuanced answers. Were you going to say something, Barth? Okay. No, yeah, I was going to say, I mean, I think it's hard to answer. I recognize that, and I guess also given the roles and the perspectives that you guys have, where it's really the integration of different SNT areas or different technologies, I guess it's probably difficult to just pick one. That might be a priority. I want to ask about the question of how do we keep programs relevant over the span of their lifetime. So I think, Trenton, you mentioned LCAPS is a 10-year program as of today, or on the order of 10 years, right? But given the pace that we've seen conflicts or tensions emerge, I mean, that could be on this span of a year, maybe even less than that. So I'm kind of curious, given that it can take several years or if not decades to take a new aircraft from concept to being operationally fielded, how do you ensure that product stays relevant throughout that entire time? How do you engage operators or warfighters or other stakeholders to make sure that the program continues to evolve from a requirements perspective so that even by the time it's done, maybe 10 or 20 years later, it's still meeting the requirements it needs to?
So I'll say that we have to move faster. We have to be able to design faster and build faster. And point of clarification on the 10-year thing, that was really the start of our low-cost attritable aircraft technology initiative, the all-encompassing initiative that we envisioned from the start to do multiple, subsequent vehicle development spirals, of which XQ-58, or the low-cost attritable strike demonstrator, was the first one that was flown in 2019, and then we've had another one, 5 years later with XQ-67 as a second generation there. So we've shown, evolution and growth of multiple platforms over that 10-year time frame, and I definitely think there's opportunity to get even faster, to explore design techniques, optimization techniques. We really leveled up our ability to analyze through integration of multiple disciplines, and then through distributed computing across local networks and maybe even out in the cloud to take advantage of this massive amount of computing capability that we have. So if you can preload a lot of that, early on, and then maybe just interrogate some of those models, if you've got something in the future that, oh, well, now this need has come up. Okay, here's where we should start then for that one. Maybe you can get even farther in the design than just, conceptual or early design in it. How much more can we integrate into this tool set or process? When is it right to kind of take a step back and say, okay, we've gotten this far, now, have things changed? Do we need to go in a different direction? That kind of thing. So that's, I guess I'll leave it at that. I think there's more that we could do with building faster as well, manufacturing faster. There's, opportunities for leveraging things that commercial processes and things that might not typically be done in military aircraft, but
Okay.
I'll leave it at that.
Okay, so I guess is it fair to say, you highlighted some interesting things there. So the idea being that if you had, a modular design or a genus of different types of designs you could pull from at any given time, then with that advantage of speed, you'd be able to build as you see fit, knowing that this is the design space, this is the trade space, and if circumstances change, you'd know what design you'd actually need to execute on. Is that kind of fair?
Right.
Yeah. Okay. Anybody else want to?
I think an important piece of all of that, and I think Trenton Steam is an excellent example of this, is the vision. Yep. It takes a lot of work to be able to, and nobody has a crystal ball, unfortunately, so we can't predict the future. But those conversations with the people out in the forefront, communicating to you what it is they can't do and what it is that they would love to do, and you taking those as seeds for bring capabilities back into the conversation, but building those capabilities and potentially having a view or vision with regards to where they could go and how can I try to continue to make this relevant way beyond the point in time that I'm done executing this project, or the Air Force they've demonstrated this genus approach as an example, but way beyond that's going to have huge implications to how all the services approach these problems. And yes, there will always be need for exquisite platforms, but how can we fill the gap beyond there? And how can we think about executing missions in a totally different way? I think that vision part is a key aspect of charting your paths towards future technologies and capabilities, which it's a top problem, so we don't always get it right, but also trying to build in some flexibility with regards to that's not the direction that we needed to go, but it won't take too much to be able to shift towards where the world is continuing to move. So if we are able to build in that flexibility, which also takes costs and resources and things of that nature, so it's not always doable, but at least having the foresight with regards to where could this go is an important part of what all of us here, I guess, our day-to-day jobs. That's what we try to do and manage, and it's a tough problem, but it's also a very rewarding challenge to know that you're working such difficult and challenging problems for the warfighter.
Mm-hmm. Certainly in the Army, that vision means constantly testing assumptions. It's probably been in the news that we had, and everyone's aware, we had a rebalancing this year of shifting to different systems from what we had previously been working on. The good part about that, if I can try to draw some attention to some of the better aspects, is that a lot of our legacy platforms were solid designs to start with that we could fall back on while we're waiting for the future to come. And when you follow good design principles, things like low empty weight fraction, it makes things like a modular system architecture possible where we can repurpose, or at least the ideal of it, one aircraft to several possible missions. Another part of that testing of assumptions is experimentation. Certainly in our office, we support operational simulations, where the designs that we create, we don't just leave it at that, like pictures. We've also supported programming the performance models of those conceptual designs, along with legacy designs, into operational simulations to see how they play. The Army as well runs something called Project Convergence, which is an actual experimentation where they go out in the field, test various scenarios of our aviation ConOp. And that gets filtered back to us that we can take that input into our design process.
Okay, so it sounds like really creating space and creating those opportunities for, as you said, testing assumptions and engaging with the warfighter so that you're always closing that loop is a big part of it. Okay, one other question here. Where do you see radical changes to platforms, such as blended wing bodies, sitting within the future vehicle portfolio?
I missed the last part of that.
Oh, sitting within the future vehicle portfolio, where do you see radical changes to platform designs, such as BWB or otherwise, fitting in with future fleet kind of composition?
Only speaking on the mobility side, it's it's clean sheet. It's wide open. Anything. The fleet that we have is not the fleet that we need. So when you have to reconstitute a fleet of systems, everything's on the table. So that's literally where we are, is looking at completely reconstituting. So and like I said, with the introduction of multi-domain operations and things like that, it lets you rethink everything about how you accomplish the mission that way. So you don't have to think in that linear sense anymore. Now we can go very nonlinear. So there's absolutely nothing off of the table.
Okay. Fantastic.
A clear example of that is what Barth mentioned earlier from the point of view of how do we move quickly, how do we maintain agility in our forces and go wherever we need to. Legacy systems will always have their place, but that's not what they were designed to do. So it is most definitely a critical aspect of what the future force could and should be. Those types of systems will have their place.
I think the challenges there may be in, if we're really thinking as clean as possible sheet, do we have ways to design those or analyze those systems, or are analysis techniques and processes based around a tube and wing configuration, or do they consider things like aerostatic lift or buoyant lift, right? That may blow apart, any design tool set that you're looking to use. So, do we go back to the drawing board, or do we develop things that address each one of those niches? That's a difficult challenge there that we've addressed several different ways in the past, but that's something that comes to mind when I think about, if it's really open, do we have the ability to design those, to analyze and design those different kinds of configurations.
Right, there's that increased risk element that you have to accept, right? I'm curious if Rob, do you have an opinion on this as an aircraft lifecycle person?
The title of this session being Platforms Filling Capabilities, I think that's a two-way street. And as a designer, I'll try to get to cost here in a second, but I get excited about the idea in general of making so-called non-conventional concepts seem conventional and speeding up that design cycle to get them into the fleet. That obviously does introduce some cost risk, but as Barth said, the urgency is real. A lot of these capability gaps are, when we look at what's going on out in the world, they seem like gaping holes. So I think the demand signal will overcome the fear of cost. Usually, the best way to conquer this challenging problem is to get to it. And the cost problems, yeah, they're there. They've certainly taken down a lot of notable programs, but a lot of the programs that are, we consider the historical success stories, contended with them as well.
Okay, fair. I'm going to ask one last kind of formal question, and then I have a rapid-fire Q&A for each of you. But the last formal question I want to ask is, what do you think industry contractors or your academic partners or any external partners really could be doing better or differently to support each of your efforts in your respective areas?
So I said interchange. Hopefully, because there have been, like I mentioned, our aviation rebalance in the Army, when we focus too much on the bad days and on the risk that's in the industry, it complicates our relationship with industry. Hopefully you see us, on the other hand, as the government, or at least those of us in the S&T community up here, as we can be your advocates to facilitate that acquisition relationship. Certainly in my office, because we try to be that objective voice of what aircraft are good for what capabilities and matching them up in that sense, we're very comfortable in having technical interchange and discussion with really anyone in industry, both the traditionals and non-traditionals. And our specialty, we like to think of it, is translating your technical capabilities, specifications, what your platforms can do up to Army leadership in making the case for what's good.
I think Rob hit that nail in the head. So from that perspective, just increasing communication is always useful. Industry is phenomenal at communicating what it is that they're doing, so that's always a big plus. But just getting the right people in the room is sometimes the challenge. Maybe easier said than done, but I would say we are certainly very willing and interested in having those exchanges and getting the right people in the room so that we can most effectively translate future needs to action. There's a lot of great exchanges. For example, an example of the technical interchanges. What are the companies, the private industry investing? Where do they see their future needs and technologies? Where can they take them? Being able to interact and interface with them at that stage with regards to, hey, we have this interesting idea that we're trying to invest here a little bit because we think it's important for this or that reason. Having the right people there to say, that's phenomenal, but if you could do this, it might get us a little bit more performance there or be applicable in this way or that to where we need to go. So I think that's a critical aspect of closing the loop with industry and academia and really all the players. We don't always have the greatest ideas. We try to think so, and we do a good job of trying to chart that potential path, but we don't know everything, and we don't know everything that's taking place in the technology space. So having that awareness, I think, is absolutely key.
Those are great points. I guess, one thing to develop technology, and I guess it's like the classic job interview question, what's the most important skill to have when you're working in a team is communication skills, right? Making sure that information in exchange goes well. Okay, so that brings us to some rapid-fire Q&A. I'm going to ask each of you to just give a one-sentence answer only, nothing too long, to three questions that I want to ask. And we'll start with Trenton. So what was the first major project or program that you worked on, and how did it go?
It was C-130 drag reduction, and it went pretty well, although I'm not sure that any of the technology, the devices that we added onto it have made it into operational use. Barth, you know on that one?
We're trying. We're trying to get them transitioned into the fleet.
Okay.
That's a headache we won't go into. But no, Dr. Chaudhry talked to some of that too. It's that bridging the gap of proving the technology, but then actually having it incorporated and put into the fleet. And so we've had mixed success, and we want more.
No, that's fair. And what about you, Barth? First program, project?
I was two concurrently, and they both turned out good. First one was I knew it as US-UK Ace Stovall, which now is known as the Joint Strike Fighter. And the other is when we were working on it was Tier 2 Plus, and that is now the Global Hawk. So I was working on those concurrently at the same time, and they both turned out pretty good.
Okay, very cool.
That's awesome. Well, my first program or projects that I worked with were actually in-service systems. I was an S&T, but in a totally different way. But it's systems that we developed and that we manufactured were causing some problems, let's just say that. So it was a very interesting way of doing reverse engineering to kind of tackle what was the crux of the problem, how could we fix it, and ultimately we did. So that was a fun, a needed capability that was not being used anymore because of X or Y reason, and being able to find an answer to how to solve that problem was very rewarding.
Awesome. Rob?
It literally was for future vertical lift and the early trades in it. That was the reason I got into this, because it was exciting. So I'll let you know how that turns out, but hopefully that is a call to action as well to our leadership, that we need to keep these new projects going in the pipeline to keep the workforce energized.
Okay, great. Maybe the other way back then, do you have a favorite aircraft and why? Starting with Rob.
I don't think you're going to get one from any of us. So like, we'll try to keep it under like 5 each maybe, and I'll restrict myself to helicopters.
Yeah.
So obviously I love Mars Ingenuity. It brings a smile to my face that the first thing we flew atmospherically on Mars on its own power, taking off from the ground was a helicopter. And then probably the two earthbound helicopters that I think about the most, since I take a historical perspective on things, are the Bell 47 and the Sikorsky R4, just because I guess I always somehow keyed in if that was a sign of things to come on whenever MASH was on TV. And I think it must have been pretty exciting in the services when the first production helicopters were deployed and we found out all the capabilities that those provided.
Nice. David?
I'd have to say F-14. Why? Top Gun.
Yeah.
The movie. I know, in all seriousness, that was the F-14 was growing up as a child was the first aircraft that I was just the sweeping wings, that whole mechanism and that whole aircraft in and of itself, I just thought was the most elegant thing I'd seen. Really captivated me as a child.
Okay. No, Tomcat's a great choice. Yeah. Barth?
Yeah, I can't give you any less than 3.
Oh my gosh! You said I should reframe my question. Yeah. Okay.
Well, I got it. So XB70 is just raw cool. Okay, it's just raw cool.
Okay. Yeah.
And then X55 and the XV25, they're my babies. I can't say I don't love my babies. So.
Okay. Fair enough.
Yeah, I kind of got to go the same way. I mean, besides XQ-67A, I would say X-15, XB-70, I'm with Barth on that one. Yeah, those are just two super cool. YF-23 also.
Okay.
All of which I believe you can see except for the XQ-67 in the Air Force Museum in Dayton, Ohio, where we live at. So let me know if you're planning to be in the area, and maybe I'll give you a guided tour.
All right, sounds good. I might take you up on that. The last question I have is, if you could offer one piece of advice to your younger self, what would that be? And I'll give you the hard question first.
Stick with it. Stay committed. Keep your heart. Your best days are ahead of you.
That's fair.
Advice, wow. There's more than work. To enjoy other things. Learn an instrument, play in a band, do something like that. Spread out a little bit.
I would say, don't be afraid to ask questions. As an introvert myself, I was always very skeptical about asking questions, but thankfully I grew out of it. But it's certainly very, very useful to be able to see different sides to a problem, or be inquisitive about things. would be one of the biggest things, biggest lessons I learned growing up.
Okay, thanks, David. Yeah.
I think this one's an easier one for me. Just my immediate thought was that I sat in yesterday on Norm's talk about the aircraft designers and the history of Northrop Grumman. So my advice to my younger self, and as well to if there are any students or younger engineers in the audience, is seek out veteran engineers like that. They really self-identify of the ones who want to talk to you like that. For one thing, they know where all the skeletons in the company or wherever you may work are buried. They know where all the best reports are. They're good at explaining things as well. They'll help you uniquely so, especially with your own communication, because they've been in the trenches in communicating to people like VPs and generals. And then also, people like that, you know, they've been around, and something that I have increasingly realized is they hold in their own mind and heart someone equal in age, but who mentored them. So we're talking several decades removed even. And those stories get even more interesting. And they want to tell you about those stories, but it quickly gets to really the founders of our field in general, like people who knew Orville Wright or Igor Sikorsky and were mentored by them. Don't lose sight of our connection that we have right here today to those people going further back.
Okay, fantastic. I guess with that very wise and heartfelt last note, I'll repeat something that you guys have all said, which is that we are now out of time. And I'd like to give a round of applause to our panelists today.